Let's solve another problem involving the concept of the velocity of approach. A blue ball is placed at point A. A is a point located at a distance of 125 meters in the northwest direction from the origin, as shown by the 45-degree angle. A red ball is placed at point B, and point B is located at a distance of 100 meters south of the origin. They approach the origin as shown, A with a speed of 20 meters per second and B with a speed of 16 meters per second. We have to find out if A and B would collide. Now we could do this easily using the motion equations. But the idea here is to demonstrate how this can be done using the concept of the velocity of approach. From the given data, we can compute this vertical distance and this horizontal distance, and we can compute therefore this angle, which turns out to be 25 degrees. And then in completing the triangle, we can compute this angle as 20 degrees. So OBA is 25 degrees and OAB is 20 degrees. Now we will draw the vector diagrams for the red ball and for the blue ball, and then we will resolve the vectors into their components along the line AB and perpendicular to the line AB. In one of the earlier lessons, we had developed two conditions to be satisfied to predict a collision. The first was that the components of the velocities perpendicular to the line AB should be equal. The second was that the components of the velocities along the line AB should lead to the velocity of approach and not of separation. Now the vector component of ball A perpendicular to the line AB is VA sine of 20, and the vector component of ball B perpendicular to the line AB is VB sine of 25. And we find that they are approximately equal, so this satisfies the first condition for collision. The second condition is that the relative velocity along the line AB must be the velocity of approach and not of separation. Observing the components of the velocities of A and B along the line AB, they will lead to A and B approaching each other, so we can say that this is the velocity of approach. Now we have satisfied both the conditions, so our prediction should be that this leads to a collision. Let's watch the entire animation now. So we see the final animation of the red ball colliding with the blue ball at the origin. This would mean that the minimum distance of separation is 0, since there is a collision. How long would it take for the balls to collide? We can see that ball A travels a distance of 125 meters with a uniform speed of 20 meters per second. So the time taken would be 6.25 seconds. Similarly, we could have worked it out for ball B. It covers 100 meters with a uniform speed of 16 meters per second and that would also give us a time of 6.25 seconds.